Okay guys, so today we're going to talk about Bohr models and ions, and what we want to do is to accomplish like 5 things, right? So the first one is to identify the number of electrons in a neutral atom, so an atom that just has no charge at all. Then we want to be able to draw the Bohr model for any atom, 1 through 20 on the periodic table. That basically keeps us away from dealing with the transition metals, which is an issue that we would deal with later in the class, but we don't need to worry about right now. Number 3 is to identify the number of electrons in a charged atom. So a charged atom is something that has either a positive or negative charge. We'll talk about how they get the charge and then why it matters for the Bohr model. And so number 4 is to draw that Bohr model when they are charged. And then the last thing we have to do is just be able to identify the number of valence electrons, which once we've done everything else is going to be super easy. So first things first, identifying the number of electrons. In a neutral atom, which is what we're going to start with, you could look at the periodic table. And this image here I screenshotted out of the original periodic table that you guys would have had. There's one of them in the file that you're getting for this week, but that image in the middle shows you sort of where everything is. And the thing you need to notice is that for this one, which they're showing Mercury, the atomic number is 80, and that atomic number tells you the number of protons in that atom. If you know the number of protons in the atom, you also know the number of electrons, assuming it's neutral, because if it has 80 protons, and remember a proton is a positively charged particle that's in the nucleus of the atom, so it's in the center. If it has 80 of those and it's neutral, then there must have been 80 electrons in order to cancel it out. Luckily, we're not going to be dealing with anything that has 80 electrons, but we do have to deal with things up to 20. So, basics of a Bohr model. Okay, so the basics of doing this, we're going to start off by just drawing a nucleus, and that nucleus we're going to draw by drawing a little circle. That will be the center of the atom, and inside of that nucleus we're going to draw or write the number of protons. So if this was, for example, a carbon atom, we would have 6 protons, so we could write 6 and then a lowercase p with a plus sign in the corner that stands for protons. And that just says in this nucleus we have 6 of those little positively charged protons. And then we need to place the electrons around the outside because they're in the electron cloud. And the way we're going to do that is to draw a ring around our nucleus and then place electrons on it. Those electrons are going to be little negatively charged things, and so we're going to symbolize those by drawing, and I'm going to erase a little spot here for just a second so I can put an electron in there. We're going to symbolize those electrons with a little negative charge with a circle drawn around it, and that's going to be our electron. So what I've said here is in this first ring, and those rings are energy levels, that first energy level has 1 electron. I need to get 6 of them to match the 6 protons in the center, so I can erase a little bit over here. Again, you wouldn't have to do this whole erasing thing, but just so you can see it on the computer. And I put another negative over here. When we do that, that first energy level can hold 2. So energy level number 1 holds 2 electrons. Every ring after that, every circle or energy level can hold up to 8. Now that's where things get a little complicated because there are 8 positions where those electrons can be. So I can have 2 up here at the top. I can have 2 on the sides, I can have 2 on the bottom, and I can have 2 on the left. So those are my 8 possible positions. Again, I'm forming a ring here. This would be my second energy level or second ring. And the key here is when I go to put my next electron in, I can put it in any of those positions. So I'll pick over here on the right. But the next electron can't go in the spot next to that first one until all of the sides have at least 1 electron. So my next one may go on the left, and then I can put 1 on the top, and then I can put 1 on the bottom. And so this would be my Bohr model. Now normally I wouldn't have these little circles drawn because I haven't used those spots yet. So I can just get rid of those. But this would be a decent Bohr model for carbon, right? I have 2 on the first ring, 4 on the middle ring, or 4 on the second ring, and then I don't have a third ring yet because I didn't have enough electrons to need it. So if we clear our canvas here, and we look back at our presentation, we're going to draw a Bohr model for phosphorus. We're just going to use this as our sort of example. So I look at the periodic table. When you look at yours and you look at phosphorus, you'll see that phosphorus has 15 for its atomic number. Again, that's the number right above its symbol. So the P is the symbol for phosphorus. 15 right above it says that it has 15 protons, which means we need 15 electrons. So we go back to our drawing and we say, okay, we have a nucleus then, and we're going to have 15 protons. I'm going to draw a circle, and then we can say, well, 2 electrons will be on that first energy level, and since I have colors here, I'm just going to, that is way too big. Sorry about that. All right, so I have an electron here, an electron there, and then I'm going to draw ring number 1. So if energy level number 1 has 2 electrons in it, I've taken care of 2 of my 15. And keep a little tally over here and say, okay, 15, I'm now down to 13. This next ring, we said each ring after the first one can hold 8. So I'm going to place 8 electrons. It doesn't matter how I place them because I know I'm filling up that ring, right? I definitely have 8 left because I have 13. So I'm going to put top and then side. Now, if I wasn't going to completely fill this ring, I'd care a lot more about where these things end up. So I have now ring number 2 completely filled. That's taking care of 8 more electrons, so I can cross this off and say 13, take away the 8 I already have. I now have 5 electrons left to place. 5 is not going to completely fill up my next ring. So because I know that, I now care about this outside ring. So I'm going to say, well, I'll put 1 on the right because the first one can go wherever I want. And then basically the reason these electrons are staying or not going next to each other is because they don't want to be right next to each other, right? They're negatively charged, they'd rather be away. So I'm going to go all the way on the other side, put an electron over here. So I've got 2 of my 5. Now I got to go top or bottom. I'll go top because why not? And then bottom. Now I have used 4 of my 5, which leaves me with 1 more. Now it has to go next to something else. So I can take this thing and doesn't matter top, bottom, left, right. I'll just go over here and draw my last one and then complete this ring. And that, as bad as it looks from me having to draw on the screen, that is a Bohr model for phosphorus, right? I can look at the center and see, hey, this thing has 15 protons. That number identifies the atom, right? Right there I could tell you this is phosphorus. Then I say, okay, and it also has 15 electrons, so not only is this phosphorus with a neutral charge. All right, great. So now we know how to draw the Bohr model. If we went to the next element, we just add an extra electron. If we were going, previous elements, we would go back 1. You guys had me for class, so we already did this, right? You had that whole table you drew out that had all those main group elements, so it wasn't a big deal. All right, so Bohr model for phosphorus we just drew. But what if it's a charged atom, right? What happens if we have a charged atom? Well, the way that an atom becomes charged is by gaining or losing those electrons. So these valence electrons that are on the outside, we can take those away, right? If I took one of these electrons and I yanked it away from the atom, it went to another atom, I would have changed the charge because now, instead of having 15 protons and 15 electrons, I only have 15 protons and 14 electrons, which would give me a positive 1 charge. Now it's a weird thing to think I take something away and end up with a positive charge, but it is what it is. So we can say that ions are atoms that gain or have gained or lost electrons and become charged. There are 2 types of ions. The first one is a cation, which is a positively charged ion. An anion is a negatively charged ion. There's lots of ways you can remember that. When I was in college, they said that a cation you could remember was positively charged because cats are a positive thing. I think that's a dumb way to remember because I hate cats. So for me, I remember that cation is a positive charged thing because the T in cation, if you write a lowercase t, it kind of looks, like a plus sign. So that, that's up to you. But however you want to remember it, if you like cats, then remember it because cats are positive. Otherwise, remember it because the lowercase t looks like a positive or a plus sign. The key here in this slide, I would make sure you sort of pause on, write down, if an atom has a negative charge, it means it has gained electrons, right? It had the same number of protons and electrons. Some new electrons came in. There was no protons to cancel them out, so it became negative. If an atom has a positive charge, it means it has lost electrons, right? They were neutral, same number of protons and electrons. Some electrons left, and it became positive. Now it's weird and backwards in your brain because you're used to, if I get some more stuff, I become positive, and when I give stuff away, I become negative. But because you're giving it away and taking in something that is negative, it flips it sort of backwards. So the example, a phosphorus atom that has a -3 charge has 3 more electrons than it would normally. So if I go back to my example here, I can say, well, if this thing I suddenly found out was a phosphorus with a -3, by the way, the way you would write that is to write the symbol for the element. So in this case, a P, and then in the upper right-hand corner of that, you would write the charge for that thing. So in this case, it is a 3 negative. So we're going to add 3 electrons to this thing. I'm going to add those in blue just so we can see the new ones. So because this outer ring already had a bunch, I'm just going to pair them up because they have to. So that's my new Bohr model for phosphorus with a -3 charge. Now, it looks very much like a different element if you just look at the electrons, right? Because it has 3 more. I think that if you go 3 farther from phosphorus in your periodic table, I think you hit argon. So the electrons look like argon, but you can tell it's not argon because it's got this 15 in the center still. And the only thing that for sure tells you what element it is the number of protons. So 15 protons, it's definitely phosphorus. How would you draw the Bohr model? We just did that. Simply add the electrons for anions and remove the electrons for cations by the charge, right? If something is a +3, you take away 3 electrons. If it's a -3, you add 3 electrons in. Final thing here, what is a valence electron? Valence electrons are just the electrons in the outside ring of the atom. So in this case, our valence electrons, let's see if we can get another color in here. These, whoa, that is way too big. There we go. So our valence electrons are these 2, and the 2 on the right, the 2 on the bottom, and the 2 on the left. So phosphorus with a -3 charge has 8 valence electrons. If we were dealing with the phosphorus that didn't have that -3 charge, then we would disregard all those blue things we drew in and say it has 5 valence electrons. Now, this is really easy if you're looking at the Bohr model. So the question is, like, how can you find the number of valence electrons? Well, option number 1, draw the Bohr model, do all of that work, and then count the number in the outside ring. But it turns out the periodic table is set up to make this easier on you. So if you look at your periodic table, everything in the far left column over here, column number 1, has 1 valence electron. Everything in the second column, what we would call the alkaline earth metals, if you were there the day we colored in those periodic tables, that has 2 valence electrons. Skip the transition metals, don't worry about it. In the third row, so skipping the transition metals, then the next one that starts with boron there, they have 3 valence electrons, and then 4, and then 5, and then 6, and then the halogens over here have 7, and noble gases. Now, with the exception of helium, actually, helium just has 2, but they do have a full outside ring. Everything else in that column has 8. And so if I asked you, like, what is, or how many, for example, valence electrons are in fluorine, well, you just look over here and say, well, fluorine is the first one in the column number 7, so it has 7 valence electrons. If you guys have questions, please feel free to email me. talk to me during the office hours. If you email me and say you need to talk on Zoom or something, we can work that out. Again, hope you guys are doing well, and hope this helped. Thanks.